EM Weekly is starting right now.
So our goal with this Flood AI is can we create an intelligent system, an artificial intelligence system to better communicate this information as if you are talking to a flood expert.
Hi, and welcome to the 50th episode of EM Weekly. It has been an amazing journey to go through this process since we started about a year ago. It's been a lot of fun. The guests that I've got to meet has been just amazing. And to meet you guys out at like the IAEM conference and to other speaking events that I've been to meet people who listen to the podcast and talk about what's going on and getting your input and what we can do better and also what kind of guests and topics that we can discuss. We have the Facebook page and group, and it's been really a lot of fun to engage with people on the Facebook group. If you guys are interested in joining, it's on Facebook and find it. It's the EM Weekly group. You know, it's been great sharing those ideas and chatting with everybody on the EM Weekly group and page. We also do Monday Live on the EM Weekly page. So if you guys want to listen to what we're talking about and just kind of give some insight what's going on for the week, it's a fun thing to do. We're about to make a few huge announcements actually in the next few weeks. One is about a new program and the website format that we're changing, and Brian's been working really hard on that, doing a really great job on the back end, and we're almost ready to announce what we're doing with that, so stay tuned. And if you're on our Facebook group, we're going to make a major announcement first there, and then we'll bring it out here to everybody else. And it's a collaboration with a major California university in Orange County, and we're working on with one of our listeners, Susan. So she brought this kind of idea up, and we're revamping some stuff over there, and we're not quite ready to announce it. Almost there, and when we do, you guys will announce it here on EM Weekly. And again, we're going to do the Facebook group first, talk about it there, and chat amongst the members over there to make it a great program. So if you're not part of the group yet, it's time to join so you can get some more insight on what's going on. We also are excited to add a few new contributors to the blog. If you haven't checked out the blog yet, it's www.emweekly.com. And we have a couple new contributors over there. We're bringing another one on board, and we're really trying to expand what we're doing over there, different inputs and ideas. So if you're ever interested in writing, reach out to us, and we would love to talk about what you guys can do, and maybe we'll bring you on board. Well, I'm really excited to have Ibrahim Demir. He's a professor at the University of Iowa, and they've been doing some really, really great work on flooding. And they've come up with, it's called the Flood AI Alpha, or the Artificial Intelligence for Flooding. And they have some really cool products there. I've been checking out their website at the IIHR lab, and yeah, it's exciting stuff there. And I think the research that they're doing, I shouldn't say I think, I know that the research that they're doing there is going to impact emergency management in a positive way, or it's going to give us more tools, and it's also going to give tools to the public, and it's going to save lives. So, sir, welcome to EM Weekly, and how are you doing today?
All right, thank you, Todd. So thank you for this opportunity to provide some information about our research and some recent projects. Thank you.
Sure. So tell me a little bit about yourself and then the research that you're doing, and just how you got into it.
So my name is Ibrahim Demir. I'm an assistant professor at the University of Iowa at the Civil and Environmental Engineering Department. So currently, I'm normally trained mostly on environmental informatics. It's a relatively new field dealing with latest technologies in computer science and computer engineering and its applications on environmental science. And for the last 7 years, I'm pretty much interested on disaster-related data and information. Actually, it started, I can say it started in 2008. We had a very, very severe flooding in Iowa, the state of Iowa. It was the worst disaster in state's history, often called Iowa's Katrina. So after 2008 flood in Iowa, the state of Iowa established Iowa Flood Center at the University of Iowa in 2009 after the spring flood. And I was hired as a postdoctoral researcher in 2010, almost like a year after the establishing Iowa Flood Center. And the main functionality of the Flood Center is providing a workforce dealing with floods, especially doing research on flooding, and also creating a monitoring network for Iowa. For the last 5 and 6 years, Iowa Flood Center has deployed over 250 stream sensors and operating them in Iowa, complementary to USGS sensors. It's a very big effort and one of the densest network in the nation that is right now is in operation and providing real-time data every 15 minutes, accessible through lots of web-based systems. And another functionality, another mission of the Flood Center is creating a flood forecast model for the state, a very high resolution and advanced model for improving the forecast of flooding. And another mission is on communicating this information. And my role here started with this mission. I started at the Iowa Flood Center as a researcher to develop Iowa Flood Information System. And Iowa Flood Information System is up and running for the last 6 years and serving the public of Iowa. And we had over 300,000 unique users accessing the system. It's widely used by the local media, newspapers, lots of local websites, and also TV stations using IFIS, Iowa Flood Information System, in real-time reporting sometimes. And
that's great.
Yeah. And the mission on communicating information is very critical. It's one of the key challenges in information in the emergency management to delivering timely and relevant information to public and decision makers. So the Flood Center role started there with all these efforts, and it's a continuous effort going on right now for the last 6 years.
Awesome, right there. You know, I've been doing some research before I wanted to come and talk to you here, and I found that between 1975 and 2000, there were 170,000 worldwide deaths due to floods. And then in the United States in 2016, there were 234 deaths due to floods. That's about 84 deaths a year on average. And according to the Flood Safety Institute, 50% of those deaths were vehicle related. And the flash flood is the leading weather-related cause of death in the United States. Well, I couldn't really find any other information regarding Canada or Mexico, but that's the information I found just doing my quick research on that. And so, you know, what you're talking about, the flood that occurred, and we talk about deaths too, but it's not just deaths, it's also economic issues as well. And in California, even though we're pretty much a desert down here in Southern California, when we do have rains, we have floods. And I remember when I was working in the field of responding to multiple people getting pulled into the rivers and pulling them out of the river. And you know, every year here in California, in Southern California, in Los Angeles area, you know, there's always a few deaths due to the floods. So how does your artificial intelligence, how would that, and first of all, how can we scale that to where it's not just in Iowa, where it's worldwide, or at least, you know, and then how does that work for us as responders and emergency managers to get information into our EOCs and into our flood control areas and stuff like that? How would that work?
Sure. So let me give you some background on how we get there to the flood information system, from flood information system to the flood AI, and where we are going right now in the research. So currently, my research is mostly on information communication, scientific visualization, data integration, and cyber systems, mostly dealing with the disasters, especially flooding in Iowa. We also deal with water quality and many other problems as a researcher and a faculty myself. But one of the challenges in data communication is integration of all these data and resources. So when you think about flooding, all of these information coming from sensors, radar, satellites, and even from forecast models are all public information. But still, if you want to make a decision, if you want to learn something about what's going on right now, you have to almost visit 10 or 20 different websites, and most of them are not designed for public. They are mostly designed for researchers, technical people with lots of technical jargon and many other information together. It's not fully user-friendly, and also it's not really integrated. So the idea started for developing the Iowa Flood Information System is how we can get all this information, relevant and timely information, together into a one-stop shop system. So we started to develop this system, integrating resources, data from 20 plus agencies, institutions, and resources, and try to create a unique and unified experience for the public. And as we go along for the last 6 years, we add more and more data resources, functionality. It became one of the most comprehensive systems in the nation to communicate flood-related data and information. So we have flood inundation maps, we have rainfall forecast, rainfall conditions, we have flood forecast models, and many other information together into this single system. But still, so we always work on improving this experience for the public, for the decision makers, even though we have hundreds of different functionality, data layers, and map layers in the system. We are always looking for ways to improve this experience and how we can make it easier for public, especially for seniors or non-technical people to access this information. And the Flood AI project started from that vision. So we are looking ways to, okay, all this information, all these nice data and layers are there in a single system, but still you need to be able to access a desktop or laptop to access this web-based system, go through all these data layers, map, and you have to somehow interpret some of these information and understand this, get this knowledge. So our goal with this Flood AI is can we create an intelligence system, an artificial intelligence system to better communicate this information as if you are talking to a flood expert? Because we receive lots of calls, emails during heavy flood season, after heavy rainfall events at the flood center. So our researchers and staff try to explain this and then provide this information by phone, by email, and we have this lots of different web-based systems and cyber systems to communicate this information. But still, talking to an expert, talking to a real person is a different experience, because you can ask a very detailed question, a very specific question, and get an instant answer. So the vision is, can we create a system like this that can answer all these questions, most of these critical questions about flooding, and we can really serve thousands of people at the same time, millions of people at the same time. So the idea is how we can scale this. We cannot really have hundreds of researchers waiting on the phone, right, besides doing research, teaching, and educating workforce. But can we communicate and can we create a unique expertise like this on the system? So we started this project for the last, started 3 years ago. We worked on several different iterations. So we created a unique knowledge base with lots of questions that you can get instant answers. It's not just like a basic question and answer system. It's mostly about everything is fully integrated. So when you can ask a question, what's the flood condition for Iowa State at 5 p.m. tomorrow? So this unique question can be easily understood by the system and divided into components. Okay, this question includes a time component, a location component, and lots of context about the flooding. So the system automatically understands the intent of the question, which community, which location you're asking about, what's the time frame you are interested, and then gives you a direct answer. So the system started with this vision, and we are currently running this system in many platforms. So when you create this intelligent system, you can easily integrate to many other communication platforms. So right now, this system is running on, for example, Skype. You can ask a question through Skype. You can ask through Facebook Messenger, Microsoft Cortana, Google Assistant, and we have integration with smart devices at home. So you can talk to Google Home, Amazon Echo, or many other smart devices. And when you wake up, when you're walking around in the kitchen, you can say, okay, which location received the maximum rainfall in Iowa at 5 p.m. Yesterday? So you can get this kind of quick and very direct answers from the system. So this is the vision. This is the process. The idea here is to make information access easy and painless for public, for decision makers, as if they are talking to flood expert.
That's great. Where does the data come from? I mean, like, do you guys have sensors out there, or is it satellite? Like, where do you guys receive this information regarding the data and what areas are going to flood?
Yes. So there are lots of different data resources integrated to the system. On the sensor level, we have over 400 sensors integrated to the system that are measuring the water levels in rivers. So 250 sensors deployed by the Iowa Flood Center. We also have integrated 150 plus sensors from USGS, Corps of Engineers, and National Weather Service. These are all providing real-time data from the stream. So what's the water level for any location of these 400 points. And then we have integrated several flood forecast models. So Iowa Flood Center itself runs 3 separate models in real time that is providing forecasts for over 400,000 locations. So we are publishing only around 2,000 locations in our system where we have sensors, where we have communities. So we have flood forecast models integrated from Iowa Flood Center model, but also from National Weather Service or other available models. So you can easily compare different forecasts, how each agency institutes thinking about the upcoming floods. So this is another level of information. And then we have information from rainfall forecasts and conditions from National Weather Service, NOAA, or any other resources that provide this data. So I think we have over 20 plus data channels that we integrate through this system. But one of the challenges actually come from there. So in US, there are lots of agencies, there are lots of institutions responsible for some part of the flooding,
right,
like the flood forecast models issued by National Weather Service. There are agencies dealing with river monitoring. So there is I think a challenge in terms of the confusion of responsibility. Corps of Engineers deal with, for example, reservoirs. So each agency and institute, the federal agency, deals with a part of the flooding. So one challenge, we don't really have a unified responsibility along the flooding. And when you see reports, flooding is not really one of the top priorities, even though the damage from economic and direct and indirect damage is very high compared to most of the other disasters.
Right. It's funny you say that because, around here in California, we talk about the earthquake, but I think we've had more damage. I should say think. I know we've had more damage and more death caused by flooding every time it rains than we have had from the earthquakes. And we tend not to think about it unless it's affecting our area. One of the things that we have here in California, obviously associated with the rains, obviously, is also the mud flows and all this other kind of stuff that's associated with it. And along the same lines is what you're talking about. Now, did your model find and predict what was happening in Houston during the hurricane?
The answer to that question and more when we return from our break.
The modern emergency manager wears a lot of hats, so how do you also fit in the needs of your exercise program? It is a matter of time, and how much is your time worth? A lot. TTX Vault is the answer to getting some of that time back. We offer pre-assembled tabletops, drills, and functional exercises spanning NIMS, hospitals and healthcare, special operations, and more, all coming from the archives of the Blue Cell. Get a jumpstart on the exercise process and visit us today at www.ttxvault.com.
Emergencies happen, whether they're related to medical emergencies, threats of physical violence, weather-related, or other. One of the most difficult things during an emergency is to find help and quickly and efficiently communicate with all parties, regardless of whether you're an administrator, law enforcement, or the end user. With Titan HST, we help to store time by creating high-tech yet simple-to-use mobile-based applications that connect you with the people who can help you. At Titan HST, we believe in the power of people.
Hi, this is Todd DeVoe from EM Weekly. If your company is in the emergency management and response space, EM Weekly is a place for you to advertise. Each week, we bring in experts in emergency management, response, and leadership from around the world, and they're here to share their best practices. Our listeners are eager to learn about new products and ideas, so this is the space for you. For more information, please contact Brian at brian@emweekly.com.
Welcome back from that break, and thank you so much for listening to our sponsors. Without them, we couldn't really bring you what we have, so check them out and let them know that you came from EM Weekly. Let's continue the interview. Did your model find and predict what was happening in Houston during the hurricane?
So normally, as the Iowa Flood Center, all of our data and interest is mostly within Iowa.
Right.
We have researchers at the Civil and Environmental Engineering Department working on national, regional, or global flood models. But my interest specifically is about data integration and communication, and then Flood Center is mostly focusing on the flooding in Iowa. So I cannot really tell much, but I've seen good results. For the Flood Center model itself within Iowa has strong results in some locations and then not good results for some locations, because it's really not a solved problem. The modeling is really a challenging problem. And when you think about federal agencies, there's a real person sitting behind the computer and making this kind of decision. It's not just a model or computer decides the forecast, but also a person experienced about the area, the watershed or the community and historical flood, and then think about all the model outputs and then make a decision about issuing a warning. It's not just a computer. So our goal is to make this automated. I mean, a unique, centralized, maybe computer system, evaluating all these models, evaluating all this information, and giving a decision. But it still takes time to go there and reach that point. But in terms of the scalability, one of the questions that you asked earlier is about, can we scale this system? Can we enable this system in other areas like Texas or Florida or other places that we experience a lot of flooding? So I've seen efforts, especially in modeling. And there are national models. There are other efforts going on in terms of cyber systems. But Iowa is one of the first examples. And currently, the Iowa Flood Information System is one of the most comprehensive systems in the nation. And we have seen some other areas trying to create systems like this. And we are currently also working with South Dakota and many other areas to help them to create a system like Iowa Flood Information System. So this is the first step. So you need to bring all this information together into a single system, and then you can start thinking of this kind of future visionary systems like the Flood AI after we have all the information together. So this is the next step even for us. So after all these years of effort, we integrate all this data and information together, and now we are ready to go forward on creating an intelligent system for flooding. And Flood AI is in the making, and hopefully we are planning to launch an early beta for the public by March 2018 before the flood season.
Oh, wow, that's great.
But definitely scalability is an issue. If you want to scale to the nation, definitely this requires a big effort. And we are working on some efforts on creating a regionalized flood information system or a national flood information system through the National Science Foundation or NOAA or other agencies. So definitely we need support. We need also an integrated approach for creating a nationwide system.
So how could we, as emergency managers, how can we support you? What can we do to help you get this more visibility in our world, and also to get that funding that you need from organizations to make it nationwide?
I mean, definitely the interest, especially in this area, is critical. I mean, the awareness. So we are working hard on improving the awareness by public, how they perceive disasters and flooding, the importance of the flooding. I mean, the flood forecast, monitoring. These are all lots of efforts going on together. So you have to improve the monitoring with more sensors, low cost and affordable, and also portable sensors that you can improve the monitoring, because we need monitoring of the rivers everywhere to improve our models, improve our forecast systems, or also improve our warning and alert systems, right? And then on the second level, we need definitely efforts on improving our models, forecasts, and running this in nationwide. And also we need effort to reach the people and communicate this information better. So the Flood AI and many other systems are going on in that process, but the main thing is we need to connect better with all these agencies like FEMA, NOAA, and others. We want to make sure that we have all these tools available for them. We are researchers. We are working on the frontier of this research. When I present these systems like Flood AI or similar systems that we developed, most of the federal agencies or institutions think that, okay, this is almost like 5-10 years ahead of what we can do or what we are planning. So definitely we are working as faculty researchers, working ahead of this schedule, but we are also helping the state agencies to enable these systems right now, making this available, because these are all systems that you use daily life, especially for other tasks like Apple Siri or many other products help you to organize your life and bring the information to you. Why don't we start doing that for flooding? Why don't we do that for disasters? And we are trying to reach emergency managers, responders, to help them use these systems in real time. Another research going on right now in our group is how can we communicate this information through augmented reality or holograms. So as you are in the field as a first responder, looking for people to rescue or reach locations. As you look around to buildings and infrastructure, we can provide this real-time information overlaid on top of that real-world information. So if you can use a see-through display like a HoloLens or a similar device, you can look around and see which building has most people or most maybe damage expected in the next 24 hours. So we can bring this kind of demographics and economic analysis directly to your eyes as you are in the field working through this kind of emergency. So as an emergency responder, first responder, dealing with maybe a flood response right now after the heavy maybe rainfall or a major disaster. So we can bring this information to your eyes, to emergency personnel that works in the field. So another area that we can improve, and this definitely requires an integration and in collaboration with all these agencies. We have a strong proof of concept running for Iowa and available, and we have all these prototypes that is running in this kind of see-through displays, augmented reality, virtual reality, all these options are available, and we have many prototypes and systems that we can present and show this vision and how it can improve decision making, how it can improve the flood recovery and response efforts in real time as you are working hard on the field.
Yeah, I was just looking at your Google Glass display that you guys have on at the IIHR lab website, and everybody, you guys need to go check this out. I'll have the website down in the show notes as well, so if you guys are looking for it. But they have the Google Glass, the mock-up here, and it's really cool. I mean, it's going to give you some good information in real time. So yeah, I think that Google Glass thing is really kind of cool. And how close is that to being, real?
I mean, all these are, none of these are mock-ups. Everything here you see is our working prototypes, but as a researcher or faculty myself, I don't have the responsibility or resources to make this operational for state, for the nation, right? Because I have my responsibility mostly on the research part.
Right.
I receive funding to do the research, to create these kind of prototypes or the vision. And then I expect the agencies or other decision makers to take this effort and then scale it to the region or the state or the nation, right? So I can help them to definitely make these systems available and used in real time. So the examples that you see here, like the HoloLens, so we created a holographic experience where you can bring this kind of 3D real world information like a city, select any scenario. For example, from Iowa Flood Information System, you can select one of the 5,000 very detailed flood forecast, flood inundation maps, a flood scenario, and then you can evaluate the scenario with economic damage. So we have one effort that we did last year was bringing HAZUS data. The HAZUS is a project by the FEMA where they have flood loss and damage estimation available through this desktop application. So one challenge with HAZUS is it requires a GIS software, database software. These are all proprietary software that you have to pay for. You need a license, you need an expert to use these systems. But what we did last year was we moved all these data and information and analysis to a web-based system that it can run in real time and in seconds. So if you select a scenario, flood scenario for Cedar Rapids, like 500-year flood, we can give you, in a second, we can give you flood loss and damage estimation for the whole city under that scenario, even for individual buildings. So you can easily see the city under that scenario and understand the expected damage, economic damage, dollar damage for the structure of the building, contents of the building, for the whole city and individual buildings. So we can bring this information to your eyes through the see-through display. So when you are in the field, you can easily look around and see individual buildings, and you see this kind of small labels pop up on the building and say, okay, this building is expected to have $300,000 damage in 5 hours. And this building expects $5 million. This is $2 million. And you can easily see this kind of information labeled with the number of people, number of people with maybe low education. So you can easily integrate this kind of resilience type information, how we can see these are the low income areas, low educated areas, or this is the area where you have more senior people that they might need more maybe support to evacuate. So we can easily bring this kind of demographics, economics as well to this kind of displays. and you can make a better informed decision in integrating all these systems, all this information together as you are trying to decide or prioritize resources during a recovery effort or the response effort.
That's great. That really is. I mean, like I said before, everybody, you need to check out this website. It's the information that's on here is really cool, and the tools that are there for people to plan for and to practice flooding, what it would look like. I think it's dynamic, and we need to get behind this project and support the work that's being done here, because I think this is a game changer for flood response. This is a game changer for saving lives and economic impact that floods have on our country. You know, former administrator Craig Fugate is out going around looking and talking about floods and the impacts that they have, and obviously the fact that our insurance programs are being impacted. And I think with this software, this program, I don't want to call it software, this entire system can really assist in that planning, and even so for like city planning, so for the mitigation of the floods, when you can see what's happening and with these models. So this is really great work. So I'm looking here also at your website, and I see that you've won a few awards from some notable organizations. Microsoft specifically is the big one that I'm seeing here, and that means that there's definitely some interest behind your work. You know, are you looking at other integrating or working with other tech companies like maybe Google or like say here Microsoft or anybody else who can come together and actually put this product on the marketplace?
I mean, we have received lots of support from tech companies, mostly on the research side. So they are supporting our research, especially working on the disaster field, and also bringing AI, artificial intelligence, intelligence systems, and using their cloud resources. So most of their support is either on the hardware level, like NVIDIA and others providing GPUs and other systems. And then Microsoft, Google, and others are providing mostly funding around using their cloud resources. But these are mostly on developing this vision, developing these prototypes. So this is very limited funding for a year or two, and then you work on your research, you publish your results with their support. And this is mostly about creating a vision, creating a prototype or a state-of-the-art system in the prototype stage, and then they are not much into supporting this indefinitely for a whole state or a nation, right? Still, they are interested for us to use their resources, to use their technology to bring the system to the live stage, but still they're not fully into, I mean, still they are commercial companies. I mean, they want you to pay the usage of their resources, mostly for cloud or other technologies, but they are really interested to help us in building this vision, building this research. And I work with, as you said, I mean, we work with Amazon, Google, and Microsoft for their cloud resources, and other companies you can see on our website. We really appreciate their support to help us to create this vision and all these prototypes. But and the next step is working with the state officials, the federal government, on creating this system for a large scale for the nation, for the states that needs this kind of information, or the emergency managers that they need this information in real time.
Have you reached out to FEMA?
So we are definitely well connected with all these agencies, especially as the Iowa Flood Center, but still we are definitely presenting all our results, all our research to them, and mostly it's going slow with the current budget situations or the current challenges, but definitely we are looking into ways to make this system available to public and researchers and emergency managers as much as possible. But the communication is generally slow and taking a long time, especially going through this kind of large scale agencies and then going through these kind of big processes, especially bringing a system to nationwide or even a statewide level is not easy, and it's a big decision for them as well. So we are looking for ways to collaborate with them. There are small probably opportunities around working. So some of them have grants and proposals that you work on this kind of prototype, but even though these grants are also about creating the prototype, it's not about creating a live and operational system, because these are relatively small funding opportunities for you to present your work to them and then create a small prototype, maybe a small system that can see the vision. But the next step is still requires a large-scale integration. We are happy to work with them, especially as the University of Iowa Flash Center. We definitely are interested to help them to bring the system to the national level. It's not just about Iowa. We are here to help other states as well. I mean, we have some interesting stories, like after the disasters in Texas and Florida, we have lots of faculty that has relatives or friends in Texas or in Florida. So we really didn't have a chance to look at the situation in a system like IFIS. So we couldn't really find a good source, a good website, or a good system that we can see or get the same experience from IFIS for Texas or for Florida. It was a really big challenge, and we are seeing a good response from the public in Iowa, that they are really grateful about the Iowa Flood Information System, Iowa Flood Center, how this information could help them if it has been there in the 2008 flood, for example. So they are really grateful. Like last year, 2016, we had a heavy flood event in September. It was like 4 or 5 days of heavy rainfall, and we had over 80,000 people accessing the system in 4 or 5 days. So this is a big effort. This is a big actually milestone for us to show that this information is valuable. The people is trying to access this real-time data and information, trying to understand their situation, not just right now, but also next 5-10 days, and then make a decision. Should I evacuate? Should I put some sandbags? So they can make a decision, better informed decision through these kind of real-time and informed systems. And we really didn't see an example for Texas or Florida or other places. So we checked these systems, trying to find systems to understand the situation going on in Texas or other states. But definitely, this is a requirement. This is really a need for us to have a nationwide or regional system, at least, to help people access these information in timely and relevant information through web and many other channels.
Yes, I think that's I think this is one of these things that we really need to get behind. One more question regarding, have you reached out or have you presented to any of the emergency management organizations, like, say, the International Association of Emergency Managers? Have you done anything with them?
We don't, I don't remember exactly definitely we presented in many conferences and workshops and other places. Hopefully we have I remember having some emergency people attending these meetings, but we didn't have a chance to present directly to these organizations. But this is something maybe for us to go to next step and reach them and try to make maybe a presentation to explain our vision and available systems, what capabilities here, what we help them. But definitely we didn't have a chance to present directly to these organizations.
Wow. I'd like to see if I could work that out for you to be able to present to them, because I think this is one of the reasons why I invited you on the show, because I think we need to get this word out to everybody in the emergency management world about this great work that you're doing. So if somebody was interested in getting in touch with you, how would they do so?
So you mentioned our website, so definitely they can access my contact information on our lab website through Iowa Flood Center, and I'm also a faculty in Civil and Environmental Engineering Department. So if you just search my name, it will probably show up in the first page on Google. So definitely, I'll be happy to talk about what the capabilities are here, our vision, all these new products that can be used in real time for emergency management. And definitely, I think you'll share some information on the podcast website about my contact, maybe the link to our program here at the Flood Center, and hopefully they can reach us and then we can continue discussions.
Great. Is there anything else that we could do to help you promote this this great work that you're doing?
Definitely this is the podcast, so I think it's a good step to share this information with others, and then hopefully we'll reach more people and then show these systems. And then definitely the recent weeks after the Microsoft and another award, we have some more visibility on the web, and many people are reaching for interviews and questions and learning about the systems that are available at the Flood Center at the University of Iowa. Hopefully we'll reach more people and explain what is available. We really want these systems, and because as a faculty and researchers, I work on this vision, I work on this project, but I really like to see these these projects go live and help people, right? It's not just about a state-of-the-art system or the vision, but we really want this system to be used in real time and help people during disasters.
Oh, I think it definitely has the potential of saving lives for sure. Like I said earlier, the floods are the leading cause of weather-related deaths in the United States. So I'm sure it's the same thing worldwide. And it's just, if we could, again, invest in technology like this that's going to save lives, I'm 100% behind it. Sir, it's been a pleasure having you on the show. Is there anything else you'd like to say before we let you go?
I really appreciate this opportunity. Thank you for inviting me to this podcast. And definitely, we are here to help anyone interested in disasters, flooding, and these new technologies. I'll be happy to discuss and share all the information and resources that we have here at the Flood Center and the University of Iowa. Thank you.